Hey guys, अब हम एक न्यू क्वेश्चन देखेंगे that is integral dz upon z minus 4 into z plus 1 whole cube, and here c is mod z is equals to 1. So mod z is equals to 1, what it means is that it is a unit circle. It means this radius is 1 and center is 0 comma 0. Okay, so this is mod z is equals to 1. सो यहाँ पे देखिए हमारे पास एफ ऑफ ए क्या है. व्हाट इज एफ ऑफ ए? एफ ऑफ ए इज 1 अपॉन जेड माइनस, sorry, f of z, you can say f of z. Okay, so f of z is z minus 4 into z plus 1 whole cube. Okay, so what is the method? How are we solving this? First we will find the poles. Okay, so first we will find the poles. So for poles, what we do, we equate the denominator to 0. Here we have z minus 4 into z plus 1 whole cube equals to 0. So from here what we get, poles are 4 comma minus 1. Okay, now here you see that z plus 1 whole cube, what it means? It means z plus 1, z plus 1 and then z plus 1. Okay, so here we have 3 poles. Okay, so this is the condition of multiple poles. Okay, so we will see how we solve multiple poles. So first we will be solving for z is equals to 4. Okay, so for which method we'll be using? We'll be using the general method. Okay, so for z is equals to 4, we have f of 4 is equals to, sorry, residue of f of 4 is equals to limit z tends to 4 z minus 4 into f of z. F of z is what? 1 upon z minus 4 into z plus 1 whole cube. So from here z minus 4 will get cancelled. So from here we will have 1 by 5 whole cube, which will be equal to 1 upon 125. Okay, so next we will see for z is equals to minus 1. So you see here for z is equals to minus 1. First we will see how we find for multiple poles. Okay, this is multiple poles. So for first we will see for multiple poles. So what is the formula? It is residue of f of a, where a is a multiple pole, then limit z tends to a 1 upon n minus 1 factorial d n minus 1 upon dz n minus 1 into z minus a to the power n into f of z. Okay, so this is the formula, general formula, which we use for finding the residue of multiple poles. Okay, so this is the formula. So we'll be equating the values. Here n is the power, so here 3 is equals to n. Okay, so here n is equals to 3. So we have residue of f of minus 1 is equals to limit z tends to minus 1 upon n minus 1 will be 2. So here we have 2 factorial d2 upon dz2. Okay, dz2 and then z minus 1 plus 1. Okay, so here we have 3 upon z minus 4 into z plus 1 whole cube. So this will get cancelled. Now we'll find this. So here what we have, limit z tends to minus 1 by 2 d2 upon dz2 of 1 upon z minus 4. So what will be its value? We will be differentiating this twice. So see here, d by dz of 1 upon z minus 4, what it will give us? It will be minus 1 upon z minus 4 to the power 1 upon z minus 4. If we double differentiate this, then what we will get? We will get minus 2. Here it will be 2 upon z minus 4 whole cube. Okay, so from here we get limit z tends to minus 1 by 2 into 2 upon z minus 4 whole cube. Okay, so this 2 will get cancelled, and then we will be putting z is equals to minus 1 in this, and what will be z of minus 1? 1 upon minus 5 to the power 3, which will be equal to 1 upon minus of 125. So okay, so here you see this. So what we get is f of residue of f of minus 1 is equals to minus 1 by 20 minus 1 by 25, and residue of 4 is equals to 1 by 25. Okay, so our final answer will be, here we have integral 1 upon dz upon z minus 4 into z plus 1 whole cube. So it will be equal to 2 pi iota into residue of f of 4 plus residue of f of minus 1. Okay, so which is equals to 2 pi iota into plus 1 by 125 minus 1 by 125, which is equals to 0. Okay, so answer is 0. So one thing is to be noted that if we have multiple poles, we have n numbers of poles. Okay, so consider if we have z upon z minus a1 into z minus a2 into z minus a3 and so on. Okay, so what will be the formula for residue? In that case, we will be writing integral fz dz is equals to 2 pi iota into residue of f of a1 plus residue of f of a2 plus residue of f of a3, okay, and so on. So the residues will get added and then multiplied to 2 iota will be the integral of this. Okay, so I hope you understood this. If you understood this, then you may comment. Thank you.